2023 rankers, top rankers. This is Umamaheshwara Rao. Today I would like to discuss revise engineering mathematics part 2, that is calculus. Yesterday I have completed linear algebra. Unacademy All India mock test for GATE 2024. Get an exam like experience for GATE. Get an exam like experience for GATE on 21st January and 28th January. Unacademy is announcing Prarambh batch for GATE ESC PSCs 2025. Batch commences from January 18th. Unacademy is announcing Vishwas batch for GATE ESC PSCs 2026. Batch commences from January 18th. List of books home delivered within 15 days for iconic subscriptions only. Unacademy is congratulating GATE 2023 top rankers. Welcome to the practice session on engineering mathematics. Today our discussion is on calculus. Limit extends to infinite. E power 1 by 5x minus 1 into 5x plus x by 5 into sine 1 by x. X by 5 sine 1 by x. That is, when x is tending to infinite, 1 by x is tending to 0. E power 1 by 5x minus 1 by 5x plus limit 1 by x tends to 0. E power minus 1 by 5x minus 1 into 1 by 5 into sine 1 by x by 1 by x. When 1 by x is tending to 0, e power 1 by 5x minus 1 by 5x is 1. This is 1 minus 1, 0, 0 into 1 by 5. This is 0 into 1 by 5 into 1. Finally 0. 1 plus 0 is 1. Therefore, the value of limit is 1. Yeah, good afternoon Akshay and Anil. The values of a and b for which the function f of x is continuous everywhere. See, if the function is continuous everywhere, the function is continuous at x equal to 1 as well as at x equal to 3. Function is continuous at x equal to 1 and continuous at x equal to 3 means left hand limit equal to right hand limit equal to functional value at that point. F of x is 2x plus 1, x less than or equal to 1, ax square plus b. When 1 less than x less than 3, 5x plus 2a. When x greater than or equal to 3, left hand limit equal to right hand limit. When x is tending to 1 from left, 2 plus 1, 3, right hand limit, a plus b. When x is tending to 3, 9a plus b equal to 15 plus 2a. Seven a plus b equal to 15. Called it equation 2. From 1 and 2, we can conclude that a is 2, b is 1. Finally, a is 2 and b is 1. Limit x tends to 0. X into e power x minus 1 plus 2 into cos x minus 1 by x into 1 minus cos x. It is 0 by 0 form. When limit is 0 by 0 form, we have to apply L'Hospital rule. Differentiation of numerator is x into e power x plus e power x minus 1 into 1. Differentiation of 2 cos x is minus 2 sin x. Differentiation of 1 minus cos x is sin x. 1 minus cos x into differentiation of x is 1. Limit x tends to 0. X into e power x plus e power x minus 1 minus 2 sin x by x sin x plus 1 minus cos x. When x is tending to 0, numerator is 0. Denominator is also 0. 0 by 0 form. Limit x tends to 0. X into e power x plus e power x. Differentiation of e power x minus 1 is e power x. Differentiation of minus 2 sin x is minus 2 cos x. Differentiation of x sin x is x into cos x plus sin x. Differentiation of minus cos x is plus sin x. When x is tending to 0, numerator is 0. Denominator is also 0. 0 by 0 form. Differentiation of x cos x. Cos x minus x sin x. Differentiation of sin x is cos x. X into e power x plus e power x. Differentiation of e power x is e power x. Differentiation of e power x is e power x. Differentiation of 2 cos x is plus 2 sin x. When x is tending to 0, it is 1 plus 1 plus 1 by 1 plus 1 plus 1, 3 by 3. That is 1. Final answer is 1. Understood? Next problem. limit x tends to pi by 2 sine square to x by x minus pi by 2 whole square, then L is, then what is the value of limit? Limit x tends to pi by 2 sine square to x by x minus pi by 2 whole square. When x is tending to pi by 2, numerator is tending to 0, denominator is also tending to 0. 0 by 0 form. Limit x tends to pi by 2. Differentiation of numerator is 2 sine 2x. Differentiation of sine 2x is 2 cos 2x by 2 into x minus pi by 2. When x is tending to pi by 2, sine 2x into 2 cos 2x, that is sine 4x by x minus pi by 2. When x is tending to pi by 2, numerator is sine 2 pi tending to 0, denominator is also tending to 0, 0 by 0 form. Now apply El Hospital rule. Limit x tends to pi by 2 sine 4x 4 cos 4x. Differentiation of x minus pi by 2 is 1. Finally 4 cos 2 pi, that is 4. Final answer is 4. Let f of x is sin x by x. F of x is sin x by x. Let f of x is sin x by x. X not equal to 0. When x equal to 0, it is 1. Then observe here, our job is to calculate f dash 0 is 0 or 1, whether function is differentiable or not. As per the definition of differentiability, f dash of 0 is limit x tends to 0, f of x minus f of 0 by x minus 0. Limit x tends to 0, sin x by x minus f of 0 is 1 by x minus 0 is x. Limit x tends to 0, sin x minus x by x square. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. 0 by 0 form. When limit is 0 by 0 form, we have to apply El Hospital rule. Differentiation of denominator is 2x. Differentiation of numerator is cos x minus 1. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. 0 by 0 form. Next. F dash of 0 is limit x tends to 0. Differentiation of cos x minus 1 is minus sin x by differentiation of 2x is 2. Finally, it is 0. Finally, f dash 0 is 0. The function is differentiable at x equal to 0 and f dash 0 is 0. Understood? Yeah, next problem. f of x is x power a sine 1 by x when x not equal to 0, which is 0 when x equal to 0. Now observe, f dash of 0 is limit x tends to 0, f of x minus f of 0 by x minus 0. That is, limit x tends to 0, x power a into sine 1 by x, f of 0 is 0 by x, limit x tends to 0, x power a minus 1 into sine 1 by x, which exists f dash 0 exists finitely when a minus 1 is greater than 0. That means a greater than 1. Therefore, f of x is a differentiable for all x when a belongs to 1 to infinite. A belongs to 1 to infinite. A function f of x is defined as f of x equal to e power x when x less than 1, log x plus ax square plus bx when x greater than or equal to 1. Whether the function is differentiable at 1, if it is differentiable at 1 for unique values or for all values, we have to identify. Now, f of x is e power x when x less than 1, log x plus ax square plus bx when x greater than or equal to 1. Left hand limit equal to right hand limit equal to functional value at 1. E equal to log 1 plus a plus b. Called it equation 1. Now, f dash x is e power x. Differentiation of log x is 1 by x to ax plus b when x less than 1, when x greater than or equal to 1. Left hand derivative equal to right hand derivative. When x is tending to 1, left hand derivative is e, right hand derivative is 1 plus 2a plus b. 2a plus b equal to e minus 1. Called it equation 2. From 1 and 2, a plus b is e, 2a plus b is e minus 1. A minus 2a is minus a, e cancel 1. So a equal to minus 1. b equal to e plus 1. Okay na? So for a equal to minus 1 and b equal to e plus 1, the function is differentiable at x equal to 1. So the function is differentiable at x equal to 1 for unique values of a and b. For unique values of a and b. I hope you understand this problem. Yeah, next one. F of x is mod x whole cube, where x is real, then the function f of x at x equal to 0 is, the function is mod x whole cube, f of x is mod x whole cube is nothing but minus x cube when x less than 0 plus x cube when x greater than 0. Left hand limit is 0. Right hand limit is 0. Therefore, f of x is continuous at x equal to 0. F dash x is minus 3x square when x less than 0 plus 3x square when x greater than 0. Left hand derivative is 0. Right hand derivative is also 0. Left hand derivative equal to right hand derivative. Therefore, f dash 0 exists finitely. F dash 0 exists finitely. F double dash x is minus 6x when x less than 0 plus 6x when x greater than 0. Left hand derivative is 0. Right hand derivative 0. F double dash 0 exists finitely. Therefore, 2 times it is differentiable. Now third time. Minus 6 when x less than 0 plus 6 when x greater than 0. Left hand derivative is minus 6. Right hand derivative is plus 6. Left hand derivative not equal to right hand derivative. Therefore, f triple dash 0 does not exist. F triple dash 0 does not exist. Twice differentiable but not thrice is the correct answer. Twice differentiable but not thrice. Twice differentiable but not thrice. Understood? Next problem. By applying Lagrange's mean value theorem for the function f of x equal to 1 plus x log 1 plus x on closed interval 0 comma 1, the value of c is. See, if you apply Lagrange's mean value theorem for the given function, then what is the value of c? f of x is 1 plus x log 1 plus x on closed interval 0 comma 1. F dash x is 1 plus x into 1 by 1 plus x plus log 1 plus x into differentiation of 1 plus x is 1. 1 plus x log 1 plus x, which is finite for all x belongs to 0 comma 1. Okay na? Now f dash x is finite. Now by Lagrange's mean value theorem, f dash c equal to f of 1 minus f of 0 by f of 1 minus f of 0 by 1 minus 0. F dash c is 1 plus log 1 plus c. F of 1 is 2 log 2. F of 0 is 1 log 1 by 1. One plus log 1 plus c equal to log 4. 1 is equal to log 4 minus log 1 plus c. That is 1 is equal to log 4 by 1 plus c. E equal to 4 by 1 plus c. 1 plus c equal to 4 by e. C equal to 4 by e minus 1. C equal to 4 minus e by e. Which belongs to 0 comma 1. The value of c is 4 minus e by e. A curve C is defined as x equal to a cos cube theta, y equal to a sin cube theta in the interval 0 comma pi by 2. What will be the point P on the curve C where the tangent to the curve is parallel to the curve joining 2 points A0 and 0A? X equal to a cos cube theta, y equal to a sin cube theta in the interval 0 comma pi by 2. Both cos cube theta and sin cube theta are continuous as well as differentiable. Therefore, both the conditions of Cauchy's mean value theorem are satisfied. Let us say this is F, this is G. Both F and G are continuous, F and G are derivable. That's why I am applying Cauchy's mean value theorem. F dash theta by G dash theta equal to F of pi by 2 minus F of 0 by G of pi by 2 minus G of 0. Differentiation of F with respect to theta. a into 3 cos square theta into minus sin theta by a into 3 sin square theta into cos theta. Functional value at pi by 2, 0. Functional value at 0 is a. G of pi by 2 is a. G of 0 is 0. Now, after cancellation, minus cos theta by sin theta equal to minus a by a. Cot theta equal to 1. Theta equal to pi by 4. X equal to a cos cube pi by 4. Y equal to a sin cube pi by 4. X is equal to 1 by root 2 whole cube means 2 root 2 na, a by 2 root 2. Y is a by 2 root 2. Finally, the point is a by 2 root 2 comma a by 2 root 2. Understood? At the point a by 2 root 2 comma a by 2 root 2, the function is, the tangent is parallel to the curve joining 2 points. Understood? Next problem. F dash x is 1 by 3 minus x square. F of 0 equal to 1. Then the lower bound and upper bound of f of 1 estimated by mean value theorem. Here given that one by 3 minus x square, f dash x is greater than 0 for all x belongs to 0 comma 1. Therefore, f dash of 0 less than f dash c less than f dash of 1, because the function is increasing in the interval 0 comma 1. F dash of 0 is 1 by 3 minus 0. F dash of c. F dash of 1 is 1 by 3 minus 1. 1 by 2 by Lagrange's mean value theorem, 1 by 3 less than f of 1 minus f of 0 by 1 minus 0 less than 1 by 2. 1 by 3 less than f of 1 minus f of 0 less than 1 by 2. Since f of 0 is 1, 1 by 3 less than f of 1 minus 1 less than 1 by 2. Therefore, 1 plus 1 by 3 less than f of 1 less than 1 plus 1 by 2. 1 plus 1 by 3 is 1.33 less than f of 1 less than 1.5. So finally, the lower bound and upper bounds of f of 1 estimated by mean value theorem are 1.33 and 1.5. F of theta is sin theta cos theta tan theta sin pi by 6 cos pi by 6 tan pi by 6 sin pi by 3 cos pi by 3 tan pi by 3. See, sin theta and cos theta are continuous for all values of theta. Tan theta is also continuous in the interval pi by 6 comma pi by 3. Generally tan theta is discontinuous at pi by 2 na, but pi by 2 not belongs to this interval because it is 30 degrees to 60 degrees. That's why in the given interval f of theta is continuous. First point. f of theta is continuous for all theta belongs to pi by 6 comma pi by 3. F of theta is differentiable for all theta belongs to pi by 6 comma pi by 3. Functional value at pi by 6 equal to functional value at pi by 3. So f of theta satisfies all three conditions of Rolle's theorem. F of theta satisfies all three conditions of Rolle's theorem. Observe here. If the function satisfies all three conditions of Rolle's theorem, there exists at least one point where tangent is parallel to horizontal line. Because if the function satisfies all three conditions of Rolle's theorem, definitely there exists at least one point where the tangent is parallel to x-axis. Understood? At that point slope is 0, f dash theta equal to 0. That's why first statement is true. See, sir, at least at one point tangent is parallel, okay. At other points tangent is not parallel, na? So here tangent is not parallel to x-axis. Here tangent is not parallel to x-axis. Their slope is non-zero. That's why there exists at least one theta such that f dash theta non-zero. That is also true. So here two statements are true. Both 1 and 2 are true. That's why correct answer is third option. Both 1 and 2 is the correct option. Understood? A function y is equal to 5x square plus 10x is defined over open interval 1 comma 2. At least at one point in this interval, dy by dx is exactly. See, it is a problem on Lagrange's mean value theorem. Y is 5x square plus 10x. Dy by dx is, because it is a polynomial. Every polynomial is continuous as well as differentiable by Lagrange's mean value theorem. Okay na? So now f of 2 minus f of 1 by 2 minus 1 by Lagrange's mean value theorem. F of 2 square is 4 5 are 20, 20 plus 20 40. F of 1 is 15 by 2 minus 1 1, that is 25. Dy by dx is exactly equal to 25. Dy by dx is exactly equal to 25. Next problem. For e power minus x, The linear approximation around x equal to 2 is, the linear approximation around x equal to 2 is, the linear approximation around x equal to 2, f of x is e power minus x na? Calculate f dash x, because problem is designed on linear approximation, that is minus e power minus x. F of 2 plus x minus 2 into f dash 2 e power minus x is e power minus 2 plus x minus 2 into f dash 2 is minus e power minus 2 1 minus x plus 2 e power minus 2 of 3 minus x e power minus 2 of 3 minus x. Next problem. In the Taylor series expansion of e power x about x equal to 2, the coefficient of x minus 2 power 4 is, fourth derivative of f at 2 by 4 factorial. Now f of x is e power x, f dash x is e power x, f double dash x is e power x, f triple dash x is e power x. Fourth derivative of f is e power x. Fourth derivative of f at 2 is e square, that is e square by 4 factorial. Final answer is e square by 4 factorial. Next problem. The Taylor series expansion of f of x equal to sin x by x minus pi at x equal to pi. At x equal to pi, let us take x minus pi equal to t, x equal to pi plus t. The function f is sin of pi plus t by t, sin 180 plus theta, sin 180 plus theta minus sin theta minus sin t by t, that is minus of t minus t cube by 3 factorial plus t power 5 by 5 factorial by t, that is minus of 1 minus t square by 3 factorial plus t power 4 by 5 factorial and so on, minus 1 plus t square by 3 factorial minus t power 4 by 5 factorial and so on, In the place of t substitute x minus pi, that is minus 1 plus x minus pi whole square by 3 factorial minus x minus pi whole power 4 by 5 factorial and so on and so on. So minus plus. Next problem. The Taylor series expansion of 3 sin x plus 2 cos x is 3 sin x plus 2 cos x is 3 sin x plus 2 cos x is that is 3 times of x minus x cube by 3 factorial plus and so on plus 2 times of 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. That is 3x minus x cube by 2 plus 2 minus x square plus x power 4 by 12 and so on. Therefore, f of x is 2 plus 3x minus x square minus x cube by 2 minus x square minus x cube by 2 plus x power 4 by 12 2 plus 3x minus x square minus x cube by 2 let f of x equal to e power x plus x square for real x. So we have to calculate f expansion of f of x equal to e power x plus x square, which includes all powers of x less than or equal to 3, which includes all powers of x less than or equal to 3. Observe, f of x is e power x into e power x square 1 plus x square by 2 factorial plus x cube by 3 factorial multiplied with 1 plus x square plus x power 4 by 2 factorial not required. Observe. X square plus x cube 1 by 2 plus 1 is 3 by 2 x square 1 by 6 plus 1 is 7 by 6 x cube Next, the Taylor series expansion of f of x 0 to x e power minus t square by 2 around x equal to 0, f of x is a0 plus a1x plus a2x square, then the value of a2 is, observe, a2 is nothing but f double dash 0 by 2 factorial. Sir, f of x is 0 to x e power minus t square by 2 dt. F dash x is e power minus x square by 2. F double dash x is e power minus x square by 2 into minus 2x by 2 minus x into e power minus x square by 2. Now f double dash 0 is 0 by 2, that is 0. Finally, the value of a2 is 0. Next one, the values of a and b for which the function f of x is x cube plus ax square plus bx has local minima at x equal to 4, point of inflection at x equal to 1. Point of inflection at x equal to 1. Given that f of x is x cube plus ax square plus bx, f dash x is 3x square plus 2ax plus b, f double dash x is 6x plus 2a, f of x has point of inflection at x equal to 1. Point of inflection at x equal to 1. F double dash of 1 equal to 0. 6 plus 2a equal to 0. Two a equal to minus 6. The value of a equal to minus 3. F of x has minima at x equal to 4. F dash of 4 equal to 0. Four square is 16. 16 3 is 48. Four to 8a. Plus b. Now a is minus 3 na? Therefore 48 minus 24 plus b equal to 0. B equal to minus 24. A equal to minus 3, B equal to minus 24. A equal to minus 3, B equal to minus 24. Next one, for the function y is equal to 1 minus x power 4 at the point x equal to 0 is 1 minus x power 4. Y dash is minus 4x cube. Y double dash is minus 12x square. At x equal to 0, y dash 0, y double dash 0. If y triple dash non-zero, then point of inflection. But y triple dash is 24x. Y triple dash is also 0. That's why calculate fourth derivative. Yeah, fourth derivative is minus 24 negative. Negative means it attains maxima. Eventh derivative is negative, therefore it attains maxima. The function attains maxima. Maxima is the correct answer. Next problem. The minimum value of the function x cube minus 3x square minus 24x plus 100. Now f of x is x cube minus 3x square, x cube minus 3x square minus 24x plus 100 in the interval minus 3 comma 3. F dash x is three x square minus 6x minus 24. F double dash x is 6x minus 6. We have to equate f dash x to 0. Three x square minus 6x minus 24 equal to 0. X square minus 2x minus 8 equal to 0. X plus 4 into x minus 2 equal to 0. X equal to minus 4, x equal to 2. At x equal to minus 4, f double dash of minus 4 is minus 24 minus 6 minus 30, which is negative. Therefore, maxima. At x equal to 2, f double dash of 2 is 12 minus 6, 6 positive, minima. Okay na? Our problem is designed on minima. Our problem is designed on minima. 1 minute. Here roots. This is minus 4. This must be plus 2. Plus 4 minus 2. When x equal to plus 4, then at x equal to plus 4, f double dash of 4 is 24 minus 6, that is 18, positive, minima. At x equal to minus 2, f double dash of minus 2 is minus 12 minus 6 minus 18, minus 18, negative, maxima. Now, our job is to calculate minimum value. Minimum value of f of x in the interval minus 3 comma 3 is minimum of f of minus 3, f of plus 3, yeah, because we have minima at 4. 4 not belongs to the given interval. 4 not belongs to minus 3 comma plus 3. That's why I have taken minimum of only these two values. 118, 28. Among these two values, minimum value is 28. That's why final answer is 28. Understood? Four not belongs to minus 3 comma plus 3. Next problem. The number of point of inflections for the function f of x is x power 4 minus 18x square plus 9. F dash x is 4x cube minus 36x. F double dash x is 12x square minus 36. F triple dash x is 24x. Our job is to calculate point of inflection. So, at point of inflection, f double dash of x equal to 0. X square equal to 3. X equal to plus or minus root 3. At x equal to root 3, f triple dash of root 3 is 24 root 3, which is non-zero. F triple dash of minus root 3 is minus 24 root 3, which is non-zero. Therefore, number of point of inflections are 2. There are 2 point of inflections. Understood? Next problem. The function f of x has f of x comma y is 2x power 4 plus y square minus x square minus 2y. Del f by del x is 8x cube minus 2x. Del f by del y is minus 2, 2y minus 2. Next, r del square f by del x square, 24x square minus 2. S is del square f by del x del y. When you differentiate with respect to x, 0. When you differentiate with respect to y, 2. When you equate del f by del x to 0, del f by del y to 0, 8x cube minus 2x equal to 0. Two y minus 2 equal to 0. Two x of 4x square minus 1 equal to 0. Y equal to 1. X square equal to 1 by 4. X equal to plus or minus 1 by 2. 0 comma 1. 1 by 2 comma 1. Minus 1 by 2 comma 1 r. Stationary points. 0 comma 1, 1 by 2 comma 1, minus 1 by 2 comma 1 are stationary points. At 0 comma 1, at 0 comma 1, the value of r is minus 2. S is 0, t is 2. Rt minus s square is minus 4, which is less than 0. Therefore, saddle point at 1 by 2 comma 1, the value of r is 24 by 4. 6 minus 2 is 4. S0 T2. RT minus S square is 8, positive. R is 4, positive. Both are positive. Therefore, minima. The function attains minima. Minima at 1 by 2 comma 1. Next problem. Given that a function f of xy is 4x square plus 6y square minus 8x minus 4y plus 8, then the optimum value of y is 4x square plus 6y square minus 8x minus 4y plus 8. Del f by del x 8x minus 8. Del f by del y, 12y minus 4. Del square f by del x square is 8. Differentiate with respect to x0. Del square f by del y square is 12. Next, when you equate del f by del x to 0, del f by del y to 0, 8x minus 8 equal to 0. 12y minus 4 equal to 0. X equal to 1. Y equal to 1/3. One comma 1/3 is stationary point. At 1 comma 1/3, the value of R is, S is, T is. At 1 comma 1/3, R is 8, S is 0, T is 12. RT minus S square is 96. R is 8 greater than 0. So both are greater than 0 means minima. The function attains minima at 1 comma 1/3. Minimum value of f is f of 1 comma 1/3 10 by 3. F of 1 comma 1/3 it is 10 by 3. Understood? Next problem. The distance between origin and the point nearest to it on the surface z square equal to 1 plus xy is. Now the distance d is x minus 0 whole square plus y minus 0 whole square plus z square. D square is x square plus y square plus z square. That is z square is 1 plus xy. F of xy is x square plus y square plus 1 plus xy. Del f by del x 2x plus y. Del f by del y 2y plus x. Now R is del square f by del x square, that is 2. S is del square f by del x del y, that is 1. T is del square f by del y square 2. Next, equate del f by del x to 0, del f by del y to 0, 2x plus y equal to 0, x plus 2y equal to 0. By solving these two equations, we get from 1 and 2 x equal to 0, y equal to 0. When x is 0, y is 0, at 0 comma 0, the value of r as t, the value of r is 2, s is 1, t is 2. Rt minus s square is 3, which is greater than 0. Rt minus s square greater than 0. Therefore, minima. R value 2 greater than 0. R greater than 0. Rt minus s square greater than 0. Therefore, minima. The function attains minima. At 0 comma 0. Next, the functional value at 0 comma 0 is x square. X square means 0 square plus 0 square plus 1 plus xy, 0 into 0 0. Now d square equal to 1. Therefore d equal to 1. Finally, the minimum distance is 1. So the distance between origin and the nearest point on the surface is 1. Next problem. Yeah, 1 integral 0 to n, 1 minus x by n power n by n minus x dx is. Let us take x by n equal to t. 1 by n dx is dt. When x is 0, t is 0. When x is n, t is 1. Integral 0 to 1. 1 minus t power n by 1 minus t dt. Integral 1 dt is t. Integral t dt is t square by 2. Integral t square dt is t cube by 3. Integral t power n minus 1 dt is t power n by n. From 0 to 1. 1 plus 1 by 2 plus 1 by 3 plus and so on. 1 by n. Next problem. Integral 0 to pi by 4. Log 1 plus tan x dx. Integral 0 to pi by 4 log 1 plus tan x dx. we have to calculate the value of integral. That is log 1 plus tan pi by 4 minus x dx. Log 1 plus tan pi by 4 is 1 minus tan x by 1 plus tan pi by 4 tan x dx. That is 0 to pi by 4 log 1 plus tan x is in denominator. 1 plus tan x plus 1 minus tan x is 2 dx. Log 2 dx minus log 1 plus tan x dx. That is I. I equal to pi by 4 log 2 minus I. To I equal to pi by 4 log 2. The value of integral is pi by 8 log 2. Finally, the value of integral is pi by 8 log 2. The value of integral is pi by 8 log 2. Integral 0 to pi by 2. Minimum of sin x comma cos x dx. Minimum of sin x comma cos x dx. Understood? Minimum of sin x comma cos x dx. See, in the interval 0 to pi by 2, in the interval 0 to pi by 4, sin x is minimum. In the interval 0 to pi by 4, sin x is minimum. That's why I am writing sin x dx. From pi by 4 to pi by 2, cos x is minimum. Integral sin x minus cos x 0 to pi by 4. Integral cos x plus sin x pi by 4 to pi by 2. Applying upper limit minus cos pi by 4 plus cos 0. Sin pi by 4, sin pi by 2 is 1. Sin pi by 4 is 1 by root 2. That is 2 minus 2 by root 2. That is 2 minus root 2. Finally, it is 2 minus root 2. The value of integral minus pi by 2 to plus pi by 2 f of x dx is the value of integral minus pi by 2 to plus pi by 2 f of x dx is e power pi x square sin cube x dx plus minus 5 pi by 2 to plus 5 pi by 2 4 cos x dx. This is odd function. That's why the value of this integral is 0. This is even function. That's why you can write 2 times of 0 to 5 pi by 2 4 cos x dx. Therefore 8 into integral cos x is plus sin x. That is 8 into sin 5 pi by 2 is 1. Sin 0 is 0. Final answer is 8. Final answer is 8. Integral 0 to 100 pi. Integral 0 to 100 pi. Integral 0 to 100 pi modulus of sin x dx. Integral 0 to 100 pi modulus of sin x dx. Observe here, it is a periodic function with period pi. That's why you can able to write 100 into 0 to pi mod sin x dx. Modulus of sin x is sin x in the interval 0 to pi. Integral sin x is minus cos x from 0 to pi 100 into minus cos pi, so 1 minus of minus plus cos 0 is 1. Final answer is 200. Final answer is 200. Understood? Next problem. The value of integral 0 to 2 pi (3 by 9 plus sine square theta d theta). First you have to divide numerator and denominator by cos square theta. 3 secant square theta by 9 secant square theta plus tan square theta d theta. Okay na? See, f of 2 pi minus theta is f of theta. Therefore you can able to write 2 into 0 to pi 3 secant square theta by secant square theta is 1 plus tan square theta plus tan square theta d theta. That can be written as f of pi minus theta is f of theta. Therefore 4 times of 0 to pi by 2 3 secant square theta by 9 plus 10 tan square theta d theta, 12 into 0 to pi by 2, secant square theta by 9 by 10 plus tan square theta is d theta. Let us take tan theta is t. Secant square theta d theta equal to dt. When theta is 0, t is 0. When theta is pi by 2, t is infinite. That is 12 into 0 to infinite dt by 9 by 10 plus t square. Yeah, 12 into 1 by 3 by root 10 tan inverse t by 3 by root 10 from 0 to infinite. Twelve into root 10 by 3 tan inverse infinite minus tan inverse 0. 4 root 10 into pi by 2 minus 0. That is 1 minute. 1 by 3 by root 10. Okay. That is 2 pi small mistake here. By taking 10 common here, the 10 will come here na, 12 by 10. So 12 by 10. 12 by 10. That is 3 4 ja 12. Root 10 by, that is 4 by root 10. Pi by 2 minus 0. Finally 2 pi by root 10 is the answer. Understood? Finally 2 pi by root 10. Integral 0 to pi by 2 log sin x dx. Log sin x dx. Called it equation 1. Sin 90 minus x is cos x dx. Called it equation 2. Equation 1 plus equation 2 is log sin x plus log cos x dx. Log sin x cos x. 2i is log sin 2x by 2. Log 2 dx. Let us take 2x equal to t. 2 dx equal to dt. Dx equal to dt by 2. Dx equal to dt by 2. When x is 0, t is 0. When x is pi by 2, t is pi. Therefore, 2i equal to 0 to pi, 0 to pi log sin t. Dx is dt by 2 minus pi by 2 log 2. 2i equal to 2 times of 0 to pi by 2 log sin t into dt by 2 minus pi by 2 log 2. 2 to cancel. 2i is 2i is I minus pi by 2 log 2. Therefore, 2i minus I is minus pi by 2 log 2. Finally, the value of integral is minus pi by 2 log 2. Understood? So finally the value of integral is minus pi by 2 log 2. Integral 0 to pi by 2 sin power 5x and cos cube x dx. You can apply Wallis rule. Denominator starts with 8, 6, 4, 2. When power is 5, numerator starts with 4, 4 into 2. When power is 3, numerator starts with 2. Both the powers are not even, therefore 1. You can cancel 4 into 2, 4 into 2. 2 by 48 is 1 by 24. Finally, the value of integral is 1 by 24. Understood? The value of integral is 1 by 24. Integral 0 to pi. Integral 0 to pi. X into sin power 6x cos power 4x dx. See here. F of pi minus x is f of x. Therefore, the integral is pi into 0 to pi by 2 sin power 6x cos power 4x dx. Denominator starts with 10, 8, 6, 4, 2. When power is 6, numerator starts with 5, 3, 1. When power is 4, numerator starts with 3, 3 into 1. Both the powers are even, therefore pi by 2. Now after cancellation, 5 1 ja, 5 2 ja, 3 1 ja, 3 2 ja, that is 3 pi square by 2 into 2 cube, 2 power 4, 2 power 5, 2 power 9, 512. 3 pi square by 512. 3 pi square by 512. Next, the value of x sin x by 1 plus cos square x. Now, this is f of x. F of pi minus x is f of x. Therefore, pi into 0 to pi by 2 sin x by 1 plus cos square x dx. Let us take cos x is t minus sin x dx is dt. Sin x dx is minus dt. When x is 0, t is 1. When x is pi by 2, t is 0. Integral 1 to 0 integral 1 to 0 sin x dx is minus dt. 1 plus cos square x is 1 plus t square. Pi into tan inverse t from 0 to 1. Tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi by 4. Pi into pi by 4 is pi square by 4. Pi square by 4. Next, if f of x is r into sin pi x by 2 plus s, r sin pi x by 2 plus s. Now, f dash x is r pi by 2 into cos pi x by 2 f dash of 1 by 2 equal to root 2. R pi equal to 4. R equal to 4 by pi. r equal to 4 by pi integral 0 to 1 f of x dx f of x dx r sin pi x by 2 plus s dx equal to 2r by pi. Now integral 0 to 1 r value 4 by pi sin pi x by 2 dx plus 0 to 1 s dx equal to 2 by pi into 4 by pi 4 by pi after integration minus cos pi x by 2 by pi by 2 from 0 to 1 plus s into x from 0 to 1 equal to 8 by pi square. That is nothing but 8 by pi square of, by applying upper limit, minus cos pi by 2 is 0 plus cos 0 is 1 plus s equal to 8 by pi square. Finally s equal to 8 by pi square minus 8 by pi square. Finally s equal to 0. S equal to 0, r equal to 4 by pi. 4 by pi comma 0. Next problem, integral minus pi to pi by 4 square root of 1 minus cos 2x by 2 dx square root of 1 minus cos 2x by 2 dx is square root of sin square x dx integral minus pi to pi by 4 mod sin x dx. Now we have to split like this. Minus pi to 0 mod sin x dx plus 0 to pi by 4 mod sin x dx. Sir, why you have splitted like this? In the interval minus pi to 0 mod sin x is minus sin x. In the interval 0 to pi by 4 mod sin x is plus sin x. Integral minus sin x is cos x from minus pi to 0. Integral sin x is minus cos x from 0 to pi by 4. Applying upper limit, cos 0 1 minus cos pi minus 1 plus minus cos pi by 4 minus 1 by root 2 minus of minus plus 1. Finally 3 minus 1 by root 2. Final answer is 3 minus 1 by root 2. Integral 0 to infinite e power minus y cube into y power 1 by 2 dy. Let us take y cube equal to t, y equal to t power 1 by 3 dy equal to 1 by 3 into t power 1 by 3 minus 1 dt. When y is 0, t is 0. When y is infinite, t is infinite. Integral 0 to infinite. E power minus t. Y is t power 1 by 3. Whole power 1 by 2. dy is nothing but dy is nothing but 1 by 3 into t power minus 2 by 3 dt. E power minus t into t power minus 1 by 2 dt. That is 1 by 3 into gamma half root pi by 3. Final answer is root pi by 3. Observe next column. Integral 0 to 1. 1 by square root of minus log t dt. Let us take minus log t equal to x. Log t equal to minus x. T equal to e power minus x. dt equal to minus e power minus x dx. When t is 0, x is infinite. When t is 1, x is 0. Therefore, the given integral becomes infinite to 0. 0 to 1 will become infinite to 0. 1 by root x. dt is nothing but minus e power minus x dx. That is 0 to infinite e power minus x into x power minus 1 by 2 dx. X power 1 by 2 minus 1 dx. That is gamma half. Gamma half is root pi. Finally, it is root pi. Next one. Integral 0 to 1. X power 6 into square root of 1 minus x square dx. X power 6 into square root of 1 minus x square dx. Put x equal to sin theta, dx equal to cos theta d theta. When x is 0, theta is 0. When x is 1, theta is pi by 2. Integral 0 to pi by 2. X power 6 is sin power 6 theta. Square root of 1 minus sin square theta is cos theta. into cos theta d theta, that is 0 to pi by 2 sin power 6 theta into cos square theta d theta. Apply Wallis rule. Denominator starts with 8. 8642. Numerator starts with 531 into 1. Both the powers are even, therefore pi by 2. 5 pi by 2 cube into 2. 2 power 4. 2 power 4 into 2 power 4. 256. 5 pi by 256 is the answer. Five pi by 256 is the answer. Understood? Five pi by 256 is the answer. Next problem. Integral 0 to infinite x power 4 of 1 plus x power 5 by 1 plus x whole power 15 dx. Integral 0 to infinite x power 5 minus 1 by 1 plus x whole power 15 dx, x power 10 minus 1 by 1 plus x whole power 15 dx, that is beta of 5 comma 10 and beta of 10 comma 5, 2 times of beta of 5 comma 10, 2 times of gamma 5 into gamma 10 by gamma 15. Gamma 5 is 4 factorial, gamma 10 is 9 factorial, gamma 15 is 14 factorial. By simplifying this, we get 1 by 5005, 1 by 5005, the length of the arc. The length of the arc y equal to x power 3 by 2 from 0 comma 0 to 4 comma 8 comma 0. Length of the arc one plus dy by dx whole square, square root of 1 plus 9x by 4 whole power half. X varies from 0 to 4. dx. Integral 0 to 4 1 plus 9x by 4 whole power half dx. I am multiplying with 4 by 9 0 to 4 1 plus 9x by 4 whole power half into 9 by 4 dx. That is 4 by 9 half 1 plus 9x by 4 whole power 3 by 2 by 3 by 2 from 0 to 1. 4 by 9 into 2 by 3. 1 plus 9 by 4. 2 by 3 into 4 by 9. Right? 1 plus 9x by 4. 9 by 4 plus 1. That is 8 by 27 half 10 power 3 by 2 minus 1. Eight by 27 half 10 power 3 by 2 minus 1. 4 4 cancel, 9 plus 1 10. 10 power 3 by 2 minus 1. Yeah, we have to calculate length of the arc.